CPING is a concurrent ping and Traceroute program that if you were to want to download it, there's the URL, www.printmath.com/ham/cping.zip. So what does it do? Well, it just does what ping generally does, except that it does it concurrently. So you can ping a bunch of sites, and you can switch back and forth between ping and traceroute. And the traceroute will also show you a history of timing for each of those sites. What it's good for is real-time monitoring of your network. So basically at about the 1 second time scale, you can see what the performance of your network is, where you have packet loss, where you have delays in the network, and so forth. It's open source, so it runs on Linux, OS X, and Windows. So you can improve the code if you wish to. The only requirement is that if you make it better, you have to share it with everybody. It uses the curses library to actually do the display. And that has the advantage that you can remotely log into another machine, start CPING there, and see how the network performance is from a different point of view. So basically, whenever you run it, just a terminal, CPING can be run in there.
It's also got the nice disadvantage that it's broken on Windows.
Well, it's not broken on Windows. It's just that when you resize the window, you have to stop it and start it so that it can realize that the terminal size has changed. On Linux and OS X, it recognizes that to get into general, but basically the PD curses library just doesn't deal well with window resizing on Windows. If you are trying to troubleshoot a particular location, you can basically switch back and forth between traceroute and ping to basically see where it is. You know, you have a record going back, probably about 5 minutes or so, that shows you what's been going on in the network. So this is what a typical ping screen look like. Over on the left-hand side, you have the target names. You've got the IP addresses, and then you've got the actual ping responses. So the numbers in blue and green and yellow shows you what the actual ping times were for all of these responses. And then on the right-hand side, it also shows you the statistics. This is obviously a very verbose view, but there's actually a much more compact view where you can actually suppress some of those fields. So here, as an example, I'm running CPING on a Raspberry Pi with a 2.5-inch 80-foot screen. And then it integrates the buttons on the right-hand side there with the GPIO library. And you can basically use that for, like on the NetLab is where I use that. If you were to run Traceroute, you get a screen that looks something like this. And essentially what it gives you on the left-hand side is the symbolic names, the IP addresses, and then you can see the times as you progress further and further away, all of the different hops. And here you can actually see what the different colors mean. So if there's a number in blue, that means so many milliseconds. So 4 would be 4 milliseconds. If it's green, those are 10. So for example, these would be 30, 20, 20, 60 milliseconds. The yellows are hundreds. So I only see 100 here. So there was a 100 millisecond ping time. And then if it's red, that would be more than a second, so thousands of milliseconds. Or if it's an X, that packet never came back. Or if it shows as a plus, it did get a response from it at some later time, but it was outside that 1 second window. Generally, how you run this is you have a configuration file that you set up that looks kind of like an Etsy hosts table. So over on the left-hand side, you've got all of the IP addresses that you want to use. You can also put symbolic names in here if you want to do, for example, google.com or any of those. It'll do the DNS lookup for you. I just put in 8888 for Google. And then whatever the symbolic name is that you want to call this by. And I tend to use fairly short names. But unlike John, I think in terms of names rather than IP addresses. So that's what I put up. Basically, the first thing is the IP address. There can be no spaces in those. But the rest of the line is then basically what becomes the text that's shown on the screen. You can put comments in the file anywhere you need by just starting the line with a pound sign. And you can also group things. So for example, here, this is a shortened list, but I have greater than backbone, and then it will actually group these together for me, north, east. So it just gives a little bit of structure to things on the screen. This particular file is called cping.cfg. And what it will do is look for one in your home directory first. If it finds one there, it will use it. Otherwise, it will go to Etsy CPING to find one if you want to set it up system-wide. To run it, it's obviously a command line utility, so you can run it from the command line. And you basically just say CPING and whatever parameters you want. I tend to set up aliases on mine, so I typically run it as CPING minus BXT. So I just set an alias. CPING is equal to CPING minus BXT so that it runs the way that I want it to run. Of the command line parameters, there's just a couple of ones that I should point out. The first one is that CPING obviously sends out a barrage of pings at the beginning of every second. And you want to be careful that you don't overload your network connection or your hardware, either the router or the host, by trying to send out a very large number of pings in a very short period of time. So this particular parameter, minus P, sets the number of microseconds between pings. So it defaults to 1,000 microseconds. So basically once every millisecond, it'll fire those off. And if you have on the order of about 100 targets, that's going to start taking about, close to 1/10 of a second to actually fire off all of those pings. So you may want to tune that particular parameter a little bit. If you've got a good network connection and fast hardware, you can basically reduce that to, maybe 1/10 of a millisecond between pings to fire off. The other thing is how often it actually sends pings. That's done with the -S flag, and it defaults to 1 second, so it sends out this blast of pings once per second. If you're on like a satellite link and you expect those return times to be much greater, you may want to set that to like 2 seconds or maybe 5 seconds. Obviously, it slows down the refresh rate, but you may want to adjust it for that. The other two parameters here that are good for gathering statistics is -N and -O. So if you use -N, you can select a fixed number of pings. So let's say 1,000 pings there you want to measure the network statistics for. And then -O will actually output all of the responses that you saw on the screen to a file, except it'll give you a little bit more detail, as well as the summary statistics at the bottom. So you can use that to actually gather statistics about the network and then save it to a file for a while. The rest of the use of CPING is basically just interactive. So this is a summary of all of the keystrokes. You can add or remove the information to make it a little bit more detailed or less detailed. And you can also do some scrolling back and forth. So I'll just show you, this is a live view of the CPING site. on the RMHAM backbone. So you can see it's running here. On the left-hand side is basically a view of our network overall. I can make it invert the screen if this is easier for you to read, which I don't think it is. You can make it scroll from left to right. Oh, actually, here's an example. See here on top, see those pluses? That basically means that those were significantly delayed, but we did hear from them eventually. In addition, you can add the addresses or remove them as you need more space. You can actually take off all of the statistics there if you want a really long view of the actual values, but I tend to just leave them all on there. And this gives you a history that goes back about 10 minutes if you actually drag your screen over all of your windows, then you can actually get a longer history going back, but I typically just leave it running in the default mode here where it scrolls right to left and with a black background. Of course, if I switch to Traceroute, this is a Traceroute from here all the way to Grand Mesa East, which is about as far in our network as you can go. It's 11 hops. And you can see that it takes us, maybe on average about 20 milliseconds to get from my QTH here over to Grand Junction. And you can look at the progression here. We start with a response time of about a millisecond, and then it goes into the greens, which are the tens of milliseconds. So, if you look at something like this, and suddenly you see it starts going yellow instead of being green, that's typically that we failed over to a VPN or something else happened that is a little bit more not a good situation. So the question, of course, is how does this all work? Well, basically, ICMP, the Internet Control Message Protocol, has been around as long as the internet has been around. It was generally invented to debug the network, but it also is actually used for error messages. And so, for example, if a site's unreachable or something like that, ping will actually send back some responses. How this looks is basically a packet that's about 32 bytes long or a little bit longer depending on the payload. So it starts out with a regular old IP header. And the important things in here is the time to live, the protocol, and then the source and destination addresses. And what ICMP adds is the type of message and the header data. So what we're going to use in CPING is, first of all, the source and destination addresses, the time to live, and for the most part, the header data. The payload is basically a timestamp. So what you do is when you send out the packet, you timestamp it with the specific time that you sent it, and the replying station will send back that same timestamp for you in the reply packet, and then you can just difference the time between now and when it was sent to actually get the round trip time. So basically what CPING does is it sets up a single IP socket for both sending and receiving. It sends out a packet to everybody, and then it looks at the replies that come back. It identifies the packets as destined for it based on the identifier that's stored in the header. So the ICMP header is basically broken into two parts. This part, the first 16 bits is an identifier, and the second 16 bits is a sequence number. So it looks to make sure that that packet was actually destined for it by having its unique identifier in it. And then it looks at the checksum to see in that row of pings which one it needed to respond to. Of course, it can tell where it comes from because in the reply packet, the source IP address actually tells it who sent the reply. If you're running Traceroute, what you need to do is to set the time to live. And CPING works a little bit different than the regular traceroute. Normally what traceroute does is it sends out a packet with the time to live of 1 and then waits for the reply, sends out a packet with the time to live of 2 and waits for a reply. CPING just goes ahead and sends one with a time to live of 1, 2, 3, 4, 5, 6, 7, 8, and basically blasts all of those out and then see who answers. And then what you do in this time to live is basically to set the number of hops that the packet will go towards the destination. If the time to live is less than the number of packets that you want to, or hops that you want to go, of course, that device is going to recognize that this is timed out, and it will basically send a reply back that says it couldn't reach the host. And that's how you know what all of the intermediate hops in the path is. So there's a few things coming up. One of the things that I want to add still is TCP pings, where you basically do a half open, where you send the TCP connection packet, you wait for an acknowledgement, and then you send a never mind packet. So that basically just tickles the IP stack and doesn't wake up everything all up and down the stack. So that'll, it doesn't introduce a real large load. And you can use that, for example, to monitor services such as, you know, is the web server up and so forth. Also want to add something where you can actually further expand individual targets, but all of those things will happen whenever I get around to it. So again, the download is at www.printmath.com/ham/cping.zip. That will actually give you the source code, all of the different executables, as well as an update script called update cping, which if you install it according to the instructions in the README, as long as you just do update cping, it will basically go and pull the website, make sure that you have the latest version. If not, we'll download the latest version, and then you'll basically keep cping up to date that way. We started 5 minutes late, but I guess I'll try to stay on schedule here and say this is the end of my talk. Are there any questions? Stunned silence.
Nobody wants to talk this morning.
I
Well,
see
I've
that.
got a question. Why are you doing your own? Why did you reinvent GitHub?
Why did I what?
Why did you reinvent GitHub? You're doing your own check for updates, download updated source, all that stuff?
It's just easier to do on the local network, because I never have to leave the network for if I want to update the NetLab and things like that. That doesn't have access to the outside world.
Cool, thank you.
Okay, let's move on to the next presenter, which is John Maxwell.
Not really. It's actually Mark.
Oh, is Mark going to present?
Well, well, part of it.
Hang
I
on a
mean,
second. I got to figure out how to get the screen shared properly here.